Hey, welcome to another episode of Amp Up Solar Talk. Today we've got Eric Schlee, a code compliance engineer from EG4 Electronics. Today he's going to talk to us about something that sounds really technical, but affects every homeowner and installer using energy storage, UL 9540 and the testing behind it. Eric is here to help us understand what this certification means, how it keeps you safe, and what goes into achieving it. If you've got questions, be sure and drop them in the chat. We'd love for you to join in on the conversation. Eric, I'm super excited about this conversation. Thanks so much for joining us today. Welcome to the show.
Thanks for having me, Kelly. I appreciate it.
Absolutely. I've been looking forward to this for a really long time. Now, let's start with something really simple. We're going to be using some acronyms today, and we're going to be using UL and NFPA. So let's start with what those two things mean and how they work alongside each other to talk about safety standards, especially when it comes to battery safety.
Sure. So UL is Underwriters Laboratories, and NFPA is the National Fire Protection Association. So the NFPA is more based down on the code level. So this is what your installers are going to be looking at and reviewing and following on all the installs per installation. The UL, they write the standards that we use here in America. Some are also used in Canada. Those standards are written by them. They're used by all the NRTLs out there, which is another acronym. So Nationally Recognized Testing Laboratory.
Okay.
UL is also a recognized testing laboratory, one that we use at EG4 for probably 95% of all of our products is Intertech.
Okay. So Intertech does the testing?
Correct, yeah. So they don't write the standards, but they do the testing. So everybody uses the UL standards, and then they perform the testing according to those standards.
Okay, perfect. Now, we've already had a question come in. This says, hello, EG4. My question is about 9540 and 9540 with the 12,000 XP. Why won't this inverter ever be receiving that certification with EG4 batteries?
So that inverter will be receiving a UL 9540 with those batteries, as well as the 6000 XP. It will be happening this year.
Nice.
So you can look forward to that.
Great. So before we talk about UL 9540, I think for our audience especially, we need to start with UL 1973. I wanted to make sure I got those numbers right. Okay. Can you explain what that is and how it fits into the overall picture?
Yes. So the 1973 really pertains to the battery itself. So when they do the 1973 testing, you're looking at the protections, over voltage, under voltage, charge, overcharging, over discharging, protections. So it's really focused on the cells, but also the BMS, the battery management system on board, and how that performs in protecting, the battery.
Okay. So can we say that, is it fair to say that UL 1973 is more of a component or battery level certification, whereas UL 9540 is more of a system level certification?
Yeah, you could say that. So you have the 1973, which pertains to the battery, and then you also have UL 1741, which then pertains particularly to the inverter. And then when you marry those two, you end up getting an ESS, so energy storage system. In our case, it's a BEESS, so battery energy storage system. And that's where the 9540 comes in when you bring those two components together.
Great. So let's take a deep dive into that UL 9540. And I'm glad you really took the time to explain the energy storage system part of that. So thank you for doing that. What does this certification mean for energy storage system, UL 9540?
So what it means is you're essentially taking the battery and the inverter, which have been tested completely separately under their own standards. Now that you bring them together, you need to make sure that those two components are working safely together in an energy storage system. And so what we'll do is we typically take, if you take, for example, EG4 FlexBoss 18 and the outdoor wall mount, you'll have different configurations, different number of batteries, different number of inverters that you can put into an ESS. And we'll take the worst case scenario of the number of batteries and the number of inverters so that we can kind of maximize the amount of total current that you would see during the testing, which would produce the most heat. The major part of the testing is looking at temperature rise testing. We also recently introduced is sound testing, decibel testing.
Okay.
And so they take an 8-hour weighted average. Anything that would be over, I believe it's 85 decibels, would require notification that you would need hearing protection within the vicinity. Now, as far as our system goes, you're looking at fans, and it's way less than that. So, and we're actually trying to drive that even lower. So, hopefully, no nuisance from sound as far as the ESS goes.
Great. So, walk us through what, from 1973 all the way up through UL 9540, what that testing looks like. What is the process?
So the process initially is, you know which standards you're going to be looking at when you design a product.
Mm-hmm.
So we know that we're going to be dealing with 1973. We're also going to be dealing with 9540. For the inverters, it's the 1741. For all inverters, it's 1741. When you get to your grid-connected or grid-tied cell-back inverters, or hybrid inverters in our case, that's where you're looking at adding in the 1741 supplement A and supplement B, SA and SB for short. And so you design the product to first be safe and to perform, and then we also try to keep the costs, as low as possible for our customers. And so we essentially, design from the ground up for the product to follow those and to be as safe as possible, to perform exactly where we want it, and to kind of hit that price point where we can.
Okay.
And so you'll perform your 1973. You also will pull parts from other UL standards as applicable, but 1973 is the main standard for batteries. 1741 is the main standard for inverters. And then once you kind of get those together, then you look at, okay, what are we doing for ESS?
Mm-hmm.
And then that's when you do your 9540. So.
Okay. So then if we look at 9540 for ESS, that's the certification. But you mentioned 9540A, and that's the test method. What does that test method look like?
So the test method, so first of all, I want to kind of really be clear, because I do hear this confusion a lot, is 9540 is a UL standard. The 9540A is a test method, so it's not a standard. Kind of the main difference there is the test method is kind of a supplement almost to, at least in this case, the 9540. Now it's also a supplement to the 1973 because there's four different stages that you can do on 9540A. The first being the cell level test, and you then would have a module level test, unit level test, and then you can have a total system installation level test. And so the standard, when you do the testing under that, you're performing multiple different kinds of tests. So as I mentioned before, kind of over voltage, under voltage, charge, discharge. There's impact tests, drop tests. There's all sorts of testing. And so that standard covers a lot of different tests, whereas 9540A is really focused. And 9540A is really focused on the thermal runaway propagation. So we're really worried about basically fire. We're preventing fire in our battery products. And
so the EG4 batteries have something that will suppress the fire.
Yes. So they do have a fire protection module built in that automatically goes off at a certain temperature, and it will release an agent within the battery case. I will say, though, that is not going to put out a thermal runaway propagation. So when we actually go and perform the 9540A testing, the BMS is disabled. The fire suppression module that's in there is also disabled. So what we're looking at is we're gathering data. So it's which is kind of another difference between the standard and a test method.
Okay.
So we want to essentially, once we do the cell level test, we're going to drive the individual cell into thermal runaway, and we're going to capture all of the gases that come off of that, and there's going to be an analysis that's done. And then the module level is kind of where we put all the different, or all the cells together the way we would in a configuration. In our case, we do 16 cells. And then you have the case, and then you're going to then do the same thing. You're going to drive a cell into thermal runaway. You're going to see the propagation, and you're going to kind of see what the outcome is and record those results. And then if you go past that, you go into a unit level test. So same kind of thing, except now you're essentially taking multiple batteries and you're kind of putting them all in one test. And so what we'll see is you'll have what's called the initiating unit, which would be, in this case, an outdoor wall mount. So you'll have one outdoor wall mount. You'll have it full of the cells, BMS disabled, fire protection disabled. You will drive that cell into thermal runaway. You actually, one of the requirements is you have to have cell propagation. Otherwise, you're going to have to redo the test. So you get another cell that goes into thermal runaway, and then you see what happens. You record all of the data, and there's observations, there's gas collection, not to the extent of the cell level, but still gas collection. There's temperature probes that are placed all around the unit, and let's see, I'm trying to think if I'm missing anything else. There's probably something, but that kind of covers the majority of it. And then if you don't meet the certain test criteria for the 9540A, then you would end up doing like a full system installation. And in which that case, you're looking at kind of outside means, like outside of the battery, to kind of mitigate the basically what happens when you have the thermal runaway. So sprinkler systems and so forth to kind of keep things a little bit cooler, and you're essentially trying to protect the area that it's installed in from catching on fire and having any detrimental effects.
So if you don't meet the criteria, you don't just have to throw your whole thing away. There are different things that you can do to help mitigate that.
Right. And even still for like the cell, if you could not get your cell to go into thermal runaway, you could stop there, because you can't, I mean, you're not going to go any further.
Right.
And so if once you do, then you graduate to the module, and then you graduate to the unit level, and then if not, then you graduate to the installation system level. Okay.
So with an A, there has to be a B. So, and you mentioned that, and NFPA, evidently 855 is really starting to look at 9540B. Talk to me about what B is.
Yes, so the NFPA, to my knowledge, is under revision right now, and there is talk that they will be adding an actual method for what they call a large-scale fire test. So 9540A already has something in it called a large-scale fire test. However, in 9540A, there's not really any fire. You have thermal runaway, you have off-gassing, you have venting from the cells, and so, but there's not really any fire. And some of the fire marshals and other AHJs and other concerned parties are like, that's not really large-scale fire test. 9540B is trying to solve that. So they're trying to create a test method that will solve that. Right now, it's an outline, but it's a pretty good test. So it's very similar to what you see under 9540A as far as like some of the test conditions go. You have a target unit, you have initiating unit, which they would be fully stocked with cells. They would drive it into thermal runaway. You'd have off-gassing. But one large change is they basically are placing igniters external to the battery, but I think it's within an inch or half inch. And what they're trying to do is ignite the gases that come off. So there's flammable gases that are expelled during thermal runaway of the lithium iron phosphate cells, and they try to light those on fire essentially. And then we do a data recording. We do observations, and then we look at, okay, what does that do on the target packs? Do we have essentially what they do is they install probes inside of the target shells against the wall, and then they measure the temperature there to see what we run into. And then the same thing, they have some acceptance criteria for those.
Nice. So that's still kind of being developed and still looked at.
Yes, so the outline is available,
Mhm.
and we're looking heavily into how we can use that to test our products to make sure that they're safe. We really want to show our customers as well as the AHJs, that our products are very safe.
Mhm.
The problem is we couldn't just go and run a test and do a test. Nobody would accept it. So you depend on UL in this case to develop a test method or a standard or something that is universal for everyone that can be followed, and the results and the testing would be repeatable. And so
Right.
that's where we are with the 9540B, so that we can use that on our products.
Great. We do have some audience questions that I want to get to, but before we do that, I want to know, how do these testing methods, what do they mean for real world installations?
Good question. That's a great question. So under the NFPA, and I believe also the International Fire Code, by itself, when you install a BESS, you have to have a 3-foot separation between your batteries. You do have a way to reduce that, and that's through doing the 9540A large-scale fire testing.
Mm-hmm.
So if we, and which we have done, we've tested with our batteries being 6 inches apart,
Mm-hmm.
which you go through that same test criteria, you look at that same temperature data, you look at all of the acceptance results, and if at that closer manufacturer's installation instruction, essentially, you meet all that acceptance criteria, then you now have a data packet, is what I'm going to say. You now have a data packet that shows the batteries are safe to be installed like this at this closer proximity. You can go from 3 feet down to 6 inches. However, the HJs have the final say.
Mm-hmm.
So, and this, we have particularly run into this, having 9540A and having the reduced spacing and having the substantiation that we could give to the customer or give to the installer to show, yes, these can be installed closer together. The HJ gets the final say. And the part of that is, well, it was large scale fire testing, but there was no fire, right, in that testing.
Right.
And so B is where we're hoping, okay, well, let's see if we can repeat those results using 9540B, having that same close proximity,
Mm-hmm.
now actually having fire, and hopefully we can get the HJs to buy in on that. So one thing I will say too, as far as the test methods and the UL standards, when they're revised or they're created, there's these large, depending on the standards, technical committees, and they're made up from everything from manufacturers to the NRTLs. They have members. You have HJs, and the HJs encompasses everything from installers to fire marshals,
Mm-hmm.
to inspectors, and they all weigh in. And everybody weighs in. And so when these standards are created, it's not just created by an entity. It's kind of UL heads everything, but there's these technical committees that come together, and we make sure that the product is both, we can be designed and manufactured in a realistic way, but it also meets the safety and criteria that all of the HJs want to see.
Sure. And so what you guys are working on is not only is it safe, but you have the documentation to back it up.
Exactly.
Great. Let's get to these audience questions. So Pete Moore says, are you aware that customers in Santa Clara County, California, have their permits on hold waiting for EG4 to provide the UL 9540 test report to the Santa Clara County Fire Department?
So I recall a county in California, and it might have been Santa Clara, California, where there was a fire marshal that would not accept our 9540A test results for a spacing reduction between the batteries. I could be mistaken if it was Santa Clara County, but HJs can reach out to EG4 and they can request the 9540A that can be provided directly to whether it be the fire marshal, the inspector, and they can review that test report, and then they can use that data that was recorded and make their determination of whether or not they want to approve the installation. Unfortunately, that's kind of the best that we can do, is we can provide the data, but as I said, the HJ has the ultimate say.
Right. All you guys can do is provide the documentation.
Right.
Got you. So Scott Learn says, I am thinking of getting the EG4 that takes in 8,000 watts of PV and puts out 6,000 watts. Will it work with my battery bank, which are older LiPo4 batteries with no communication?
It sounds like an open loop communication scenario. I won't comment on that directly here, but I will say that we have a lot of great people that they man the phones and the emails and the forums for our support department. So I think it's support at EG4Electronics.com. If you can reach out to them, that is definitely a question that is right up their alley.
And you can give Signature Solar a call as well.
And Signature Solar.
Either way, yeah. Jeff Duffy wants to know, do both the inverter and battery need to be listed together to qualify?
If we are referring to the 9540A, or sorry, 9540, yes. So essentially, when we take the battery and we take the inverter, we're creating something new. So we're creating an ESS. It's the inverter has its own model number, which is recorded and governed under the 1741 report. And then there's also the battery, which has its own model number. And then when we bring the two together, we create a new model number. And that's the model number that actually exists on the report. It also exists on the certificate of compliance, which can be found at Signature Solar or EG4 Electronics website. And then that will show you all of the different model numbers that are captured under that testing, under that UL standard. And that's where that would be recorded. So you wouldn't really list the inverter and the battery together on the 9540. You end up having that model number, which is representative of those two.
And he says, also, is UL 9540 required by code in all states?
It really depends on the AHJ. I will say that 9540 is required under the NFPA 855. It's also a reference in the NEC. Also the International Fire Code. I know the California Fire Code. I believe possibly the building code as well. So it really depends on what the AHJ uses when they are inspecting the system and installing the system, of whether it's required or not. Should you have it? Yes, you should, because having the 9540 is that extra step that we took as a mark of safety to ensure that the system performs in the manner in which it was designed and is proven to be safe in all installations, whether you're installing something that's off-grid or whether you're installing something in Santa Clara, California, or anywhere else where the inspectors and the regulations are very high and very stringent. It doesn't really matter which side of the spectrum you're on. You should absolutely have those certifications. And that's what we strive to provide, so that we can show, yes, we have the proof the products are safe.
Yeah, we always try to say safety first, right?
Absolutely.
So we also have a question that says NFPA 855 only references lithium-ion batteries. Why is this? Why are they ignoring other chemistries like the LFP that is more common for residential ESS?
So I've seen this before. Lithium ion it's really a generic term. So lithium ion does cover the lithium iron phosphate. It also covers some of the other lithium chemistries, NMC, although I'm not sure how many people are using NMC for residential batteries. But lithium ion is where that is covered. I don't know if the 2026 version of NFPA 855 is going to kind of expand on that and maybe make more specific references to the specific types of chemistries. We've tried to be very specific on our reports and documentation. We don't just say lithium, we try to say lithium iron phosphate. So we're talking about the exact chemistry of the cell that we have. Great.
So thanks for answering those questions. Has in the past, or do you see evolving UL and NFPA standards driving battery technology changes in the industry?
Always. So all the codes and all the standards are they're stem from safety. So they're trying to make sure these products are as safe as they can be when they're installed in residential or commercial environments. And so we try to stay up on that even before we read it from the published version. We try to be as a part of groups, committees that are really driving the changes in these standards, and to know what's going to be coming and to know where the worries are, because it's kind of a great experience to be in some of the technical committees and you hear their side, you hear their worries. This is what they want to avoid. And so as the manufacturer and the designer, we can use that kind of upfront knowledge to design the products to be safe in that manner before the new standards come out or standards are changed or updated. So, but absolutely they drive the design and safety of our products.
Right. And so whereas we sometimes talk a lot about performance and longevity and things like that, they don't care anything about that. Their number one concern is safety.
Exactly.
Right.
So, and we have to balance between the two.
Yeah, as a manufacturer, for sure. So, Eric, this has been a great conversation. Is there anything else you would like to end on with this conversation?
I just want to say I really appreciate you having me on. I'm glad that we could get this information out to a wider audience. I know that it's something that some people do stumble over and have a little confusion on. We say it kind of day in and day out. So I really hope this helps all of our customers to understand the standards a little bit better, the role they play, and how EG4 is using them to make sure that we have the best and the safest products possible.
Absolutely. It's been a super valuable conversation. I've really learned some things and really enjoyed it. And I appreciate you taking what can be a super technical and high level conversation and breaking it down to where, it was simple and understandable. So thanks so much for being here. And to our audience, thanks so much for joining in on the conversation and participating. When you guys ask us questions, it helps keep this conversation relevant to what you need to know and need to hear. So thank you for joining us. If you'd like to learn more about UL certified EG4 systems and products, visit us at signaturesolar.com. Also, as always, don't forget to subscribe and follow so you never miss an episode of Amp Up Solar Talk. We'll see you next time.